Okay, here is the answers to the 714 review preview. Problem 53 says use the Pythagorean identity to find the exact coordinates of a point on the unit circle that has sine of theta equals 1/4. So remember, sine is the vertical. So 1/4, this is 1. So we can use the Pythagorean theorem. We do 1 squared minus 1/4 squared equals x squared. This is x. So I get 1 minus 1/16, or 15/16. So if I square root both sides, I get x equals square root of 15/4. 54, find the coordinates of PQ on the unit circle. So P, my angle is 50, so it's going to be the cosine of 50, comma the sine of 50, or it's going to be approximately 0.64, 0.77. Q, I'm going to use the coordinate 110, so I'm going to do the cosine of 110, comma the sine of 110. So I get approximately negative 0.342, comma 0.94. 55, it says the curved arrow represents the rotation of QR beginning from the positive x-axis through how many degrees? So it's at 60 is the degree right now. So that means it's gone 360 minus 60, or 300 degrees. So it says if QR is 1, what are the exact values? So it's a 30, 60, 90 right triangle. So OS would be 1/2. And then SR would equal the square root of 3/2. So then it says, what are the exact coordinates? So it would be 1/2, comma, a negative square root of 3/2 because of where it is on the circle. Problem 56, what angle in the first quadrant could you use a reference to help you find the sine and cosine? So you just subtract them from the closest of 360 or 180. So 330 is the closest to 360. So I'm going to get 30 degrees. 120 is closer to 180. So I'm going to get 60 degrees. 113 closer to 180. So 180 minus 113. So 67 degrees. And 2 or 3, I subtract 180 from it. So 23 degrees. Problem 57, solve. So I have to figure out how to get 1/2 and 1/8 to be the same. So I picked that I should get it to be 1/2. So I know that if I raise 1/2 to the third power, I get 1/8. So I can rewrite this as 1/8 to the 3 groups of 2x minus 3 equals 1/2 to the x plus 2. So then I just put those two together and solve. So I get 6x minus 9 equals x plus 2 minus x for both sides, add 9. So I get 7 or 5x. 5x equals 11. So x is going to equal 11/5. 65, unfortunately, so Daniel sketched the graphs at right for sine and cosine. He forgot to label the graphs. Now he can't remember which graph goes with which. So he can tell, so I can tell that the sine of theta is line 2 because it starts at 0, 0. So then cosine of theta is line 1. 67, find the x and y intercepts for the quadratic function. It's a checkpoint. It's going to make sure you know how to do this without a calculator. So for the y-intercept, we would just plug in 0 for x and get negative 17. So the y-intercept is just 0, negative 17. The x-intercept is a little trickier. I can't factor it, so I got to use the quadratic formula. So I'm going to get negative 4 plus or minus square root of 16 minus 4 times negative 17 times 1 divided by 2. So I get negative 4 plus or minus 17 times 4, 68 plus 16 is 84. So the square root of 84 divided by 2. Well, 4 goes into 84 21 times. So I get the square root of 4, which is 2. So I'm going to get negative 4 plus or minus 2, the square root of 21 over 2. I can simplify. So my x-intercept is negative 2 plus or minus the square root of 21 times 0. Solve each equation. So for the first one, I can just cross multiply. So I'm going to get 4x plus 4 equals 3x. Subtract 3x from both sides. So I get x plus 4 equals 0. Subtract 4. So I get x equals negative 4. So for b, I'm going to multiply everything times x plus 1 as I go through. So x, this is going to end up being 3x. The x's will cancel, so I get 4x plus 4 equals 2x squared plus 2x. So then I move everything over. This is 7x. 2 minus 7 is going to be negative 5. So I'm going to get 0 equals 2x squared minus 5x minus 4. So it's unfactorable. So I'm just going to use the quadratic equation. So I get 5 plus or minus the square root of 25 minus 4 times 4, negative 4 times 2. So I get 32. So 25 plus 32 divided by 4. So I get 5 plus or minus square root of 57 over 4. And then for C, I'm going to multiply everything by x plus 2. So I'm going to get 3 plus 5x plus 10 equals 3. So I get 5x equals negative 10 because 13, 3 minus 13, negative 10, divided by 5. So x equals negative 2. But since the denominator can't be 0 and negative 2 plus negative 2 is 0, the answer is actually no solution.